Okay, we are videoing sixth period today. All right.
Yeah!
All right. So well, that's definitely a higher energy beginning than I usually get.
Yes.
Okay.
Second period.
So here is what we are doing today. I have passed out the vector problem set, so there should be a copy of it at each desk. And this will be even better because this is class participation today. So there it is the opportunity for people to come up on video. All right, so just, you don't even know what I'm going to be asking you to do.
But I'm good at everything.
Okay. So the plan here is we are going to take a look at setting up problems 2, 4, and 10 off of the vector sheet. I'm going to say that these are probably the problems that are most like the vector problems that you've been doing up to this point in time, which is pretty much, here are a bunch of vectors to add together and give me a resultant. There are a couple of these that have a little bit of a twist that we will point out in the setup, but the idea is not to set up a problem and then just go dead while you solve it. We are going to set something up. I am going to, erase it. We're going to set up another one, erase it, and so forth. And then at the end of class, you can have some time to go back and finish off the problem. Also, I set up remember we were having our mini test on vectors?
Yes. Yeah.
If you have not seen your Google Classroom, I set that up for Wednesday. So I'm going to give you a half sheet of paper. One side will kind of have graphing background, and the other side will be blank. And there will be 2 problems. They will be 3 vector problems, and one of them you will do graphically on the one side, and the other one you will do mathematically on the back side. Yes?
How many points is it going to be?
I'm not sure yet. I was thinking it should be at least worth either 4 or 6. Like
Maybe 5?
2 for the graphing, 2 for the math, or 3 and 3. Or I could go in between and say 2 for the graphing, because that's kind of like you do it or you don't, and 3 for the math, because there's a little bit more work involved in that. Yes, Megan?
Will we get our papers back of like the work we've already done to like study off of?
I'm not sure you will. So your studying will have to be like with the notes that you have. And hopefully you have those basic notes, because the process is going to be pretty much break the vector, at least mathematically, break the vectors down, add all the horizontal pieces, add all the vertical pieces, do the Pythagorean step and the arctangent step. And I think the graphical edition is like, you either know how to put your protractor the right way or you don't. So that's why I didn't feel too bad about maybe not having that back to you by then, because this was pretty basic. What are you doing? Are you looking at that?
You got an email.
he was
Oh, okay.
was snooping.
Yeah. Okay. Whatever.
You turned around and you went,
Now,
"Look."
here's the way this is going to work. Everybody have their problem sheet out in front of them?
Yeah.
I'm not really doing this. You guys are. So what I need is somebody look through number 2, and what I want you to do is not do the problem up here, but I want you to make the sketch according to the description of the problem and label it as thoroughly as you think you need to, because for these problems, and for the most part, most vector problems, I find there to be a very graphic portion of them. Like if you can draw the picture the right way, that picture tells you kind of what you need to do. Yes, Johnny?
Oh, I was just volunteering to do it.
Yeah.
Oh, you're up then.
Yeah.
Okay, and you can use whatever colors you want. And so when you're done, just kind of step aside, and then we'll...
Okay.
He's never volunteered
We'll critique
before.
it.
He's just doing it for the camera.
That's
He
not
just
true.
sits here.
That's false.
That's true. This is the first
You
time.
literally never volunteered before
Okay.
in this class.
Is that straight or no?
Now, do not worry about that exactness in straight. you might want to say, try to do a little bit of scaling. Don't get crazy. It doesn't have to be perfect.
Okay. I'll do the cities in a different color.
Stop it, Nathan. Simon.
So when it says 30 degrees northwest, north of west,
Okay,
does
for
mean
that
it's-
one, and I think this is visible in the video, on the upper left there, see how I put the north, south, east, west, and the degrees like they correspond to vectors? When they say like north of west, you go to the second direction first and then rotate appropriately one way or the other. So
So
what,
it'd be one
what does
way?
it say? What is
north of west?
Okay, so pretend you go west, which would mean, and then rotate north a certain number of degrees,
Oh, so
and then
it'd be
that gives
30?
you the direction.
Oh, so like 150.
So if you were putting the 30 degrees in there, where would it go? Okay. That one people have kind of gotten mixed up and put in the wrong
Let's just throw it.
place.
Yeah, but not him. John
Okay,
Yates is
so
strong student.
It's asking us for the displacement from here to here.
Okay.
Oh.
Okay, that's good.
Make sure I didn't forget anything.
The 300 kilometers.
Oh yeah, 300
Yeah.
kilometers.
Okay,
Oh, that's kind of really off scale.
that's okay.
Let me just.
Okay, now I'm going to ask for one last thing because you kind of got the complete idea here.
Okay.
Since we're dealing with vectors,
Oh.
give me arrow indicators
Okay.
on the things you've drawn.
I would have done that. We know that he's just doing it for attention.
Okay. Very good. Okay, now that is, I'm going to say the picture drawn correctly. So now, when we look at this problem and we're asking, all right, what the hell am I supposed to do with this? This is about as easy as it gets because we're going to go ahead and call this vector A. We'll call this one vector B. And then what does the green one become?
R.
It becomes our resultant. So everything about doing our vector addition that was part of your assignment, we're going to do exactly the same way. Break these into pieces, add the pieces together, use the Pythagorean step, arctangent step, we're done. But here's where we have to do a little bit of interpreting from the picture. Because the beginning of our problem is over here where A is, and one of the things that we need to do, because there are some teachers who will say, hey, just use your cosine and sine based on what you see in the picture. I do not prefer to do that. I like people to be very rigorous about your vectors are magnitude and 0 to 360. So if we look at vector A here, if we write this in its polar coordinate form, what would it be based on this information?
A,
Yeah. What's the magnitude of A?
200.
It is 200 kilometers. And then what would the angle be because of the way it points in the picture? It would be 180. Okay? What about B? What is its magnitude?
300.
It's 300 kilometers. And then what would the angle be?
150.
It would be 150 because what we want is this angle here, not the 30 degrees that they mentioned. The 30 degrees that they mentioned only allows us to draw the picture, but then we have to reinterpret the angle. So this becomes 150 degrees. Okay? Now at this point, I'm not going to go any further because you are going to process this problem exactly like you would any of our vector addition problems we did before. But I will point out here, when you get to your last step, which is which step?
What?
Step 4, which is what are you doing mathematically there?
Inverse tangent.
You're doing the arctangent step. What quadrant, and this is where if you are way off scale, maybe you might not be able to determine exactly what quadrant you're in, but Johnny's close enough here. What quadrant is our answer pointing in?
2.
2. So when you do the arctangent step, what will you see on your calculator initially?
Beats.
It will show you a negative number of degrees, which you then have to do what to?
Add 180.
Add 180, okay? If you guys start to get comfortable thinking about that, you know, and looking at this picture going, I kind of know what to expect to get to my answer, that's the best I could hope for, okay? So, this is problem number 2 all laid out for you.
Woo.
All right? So, I'm going to erase this. So, this is where I'll say picture takers. You take the picture. If you've copied, leave some space below that. I found the coolest thing. Anybody use an iPad for note taking? I got a student in another class who uses an iPad like wonderfully, and I was asking them. I was asking them about it and saying, "Can you actually like take your notes and then if you need more space, like shuffle everything down?" They're like, "Yeah." I'm like, "Damn, that is cool."
Is it Sebastian?
Okay. No.
I know a lot of people in my math class who use iPads.
Okay. So next, who wants to do 4?
I do, but I'm scared.
McKenna, come on.
Like if I told you that this was, there is one here that is, yeah, this one's a little different.
Come on.
So, can I do it?
Oh, I'm sure you can.
Do it. Come on.
Okay, I'm on my way.
Yay.
All right.
Yay! Wait, but I don't know how to do this.
All you need to do is draw the
Oh,
picture.
This says your name on it.
Yeah, that's just so
I know,
people
but
whose it
the
is.
picture is also hard.
All right.
West. Did you know that I got a question wrong on my math test once because I thought that south was west, and then she got really mad. So that was good. 100. WTF. At the end of the run, north of east.
Okay.
East is this way.
All right. And then you would rotate up from there.
So it's up here.
Okay. What is the language
Well, no,
on there?
like, but I'm confused.
Hold on. What is the exact wording?
It says, oh, 15 degrees north of east.
Okay. And where is the runner located?
Oh, 175 meters away from the sun.
From the starting point.
Yeah, no, sorry.
Okay. So pretend, put your other finger 175 meters away. Compared to, okay, it could be anywhere in a circle. But what's the directional thing that they give you? 175 meters
North of east.
north of east. So which way is east? Rotate
Oh,
north. Okay.
I'm getting it.
So now
Can I use a different color?
find that spot.
15 degrees.
Let's see you draw that.
15 degrees is kind of small. It's like this.
Okay.
Is that fine?
That's fine.
175. Oh wait, meters.
Okay.
And then
Okay.
and then am I just connecting them?
This is the part that you got to interpret. What are we supposed to find?
Describe the length of per second display.
Because where did she start?
Here.
Then where did she go? First, there, and then where did she end up?
Here.
Okay, so, alrighty,
I just like.
okay. Now, do me a favor, just like with Johnny. Give me some arrow indicators on these guys.
Okay.
Okay? Okay?
Okay.
Now I'm going to point out there is some wording that could happen with this problem where that red one would not point that way. It would point the opposite way, and things you'd have to think a little bit more to get things right. But they only had her going through the 2 segments, and then she was displaced from the starting point. Because the other verbiage is then she runs back to the starting point, and then your picture looks a little different in terms of the arrow indicators. I think you got everything. Okay, that's the picture. Very nice.
Hard though. Ah.
Okay,
Thank you.
so
Thank you.
One clap.
Thanks.
we're doing this again, though.
Oh, I was gonna do that, but then I got scared.
No, that's all right. Okay, what is different if I go and say, what's different about the style of this problem compared to the last one?
In the first one, you're figuring out the results, and in this one, you're figuring out one of the like actual.
Correct. In the first problem, it's just like we did in our problems. Let me give you all like the constituent vectors and you find the resultant. In this one, they're giving us, well, we only have 2 constituent ones. They're giving us one of those and then the resultant, and then we have to figure out what got added to it. Now, I'm going to write some stuff up here that as far as being somebody who favors being very rigorous about their work, I favor my way. There are people, I call them my thinkers or my mentalist people, that just say, I just do it in my head. You need to remember that I need to see the work on the paper if you want full credit for this stuff. So that's why there are many people that once they look at pictures, they go, I know exactly what to do. You just add this, subtract this, and it's like you have to put on paper things that show me that's why you're doing them. So, what is my value for A? 100 meters, 180 degrees. All right? See, again, this is where some people say, it only has an X component and it's negative. Can't I just do it? At higher levels, people will let you do that. But at this level, I'm going to demand that you be very rigorous and say, look, it's 100 meters, and when you put in cosine 180 degrees, that's -1. That's why it ends up being negative. Okay, what's our R? Okay, 175 meters, 15 degrees. Now, if we were doing, and then B is just going to be, and we know that it points in the first quadrant. So here's where I'm going to show you my rigor on this. In step 2, what is it that we do? A vector addition.
Summation.
It's the summation thing where we say Rx, actually, I'll go ahead and color code to match what McKenna did here. Rx equals AX plus BX. And RY equals AY plus BY. So if we put the values that we can calculate from here into this, what thing can we calculate from this?
EX and BY.
We can calculate what is the value of bx and what is the value of by. Now, if you approach it this way, if bx or by is supposed to be positive or negative, it will automatically turn out to be positive and negative. You won't have to like, do I add or subtract them? You just do what the math tells you, and if you did your work correctly breaking these down, your x and y piece will automatically have the sign they need. Once you get the x and the y piece of your answer, because it's a right triangle, what are the next two steps that you're going to do?
The
Thingy.
thingy.
The next, what most people would do next is they do the Pythagorean step, and it doesn't matter if you go, but it's not Rx. It doesn't matter. You have the x piece and the y piece for your answer. When you have the x and y piece for your answer, you will always do the Pythagorean step to get the magnitude and the arctangent step to get the proper angle. And in this case, are you going to have to worry about anything with the angle when you do your arctangent? No, because?
You have this.
You have it already.
I don't know.
No. Once your calculator like spits out the number, that's your answer.
Oh, because it's in
Oh.
the first quadrant.
Because it's in the first quadrant. Okay. Now again, if this was like close to one of the other quadrants and the scale was not drawn properly, you would know from the sign on your x and your y piece what quadrant you're in. Okay. So far so good?
See.
So this one's a little different because we didn't give you all the pieces to add together. We gave you everything but one and then the answer and said you kind of have to figure out, but you used the same structure to do it. All right.
Johnny.
2 down, 1 to go.
Singing Johnny. Sing Garzo. You whistle. Do it.
Why is 5 green?
Okay, I will comment on that when we're done here.
Do the beginning.
Okay, number 10. Who wants to do number 10?
I don't want to do it. I'm busy.
Tony!
I don't want to.
Use camera
I
shot.
can camera shot.
Go for it. All right, Josh is going to come up and do it. This one you might want to use colors because I think there's a few different ones.
Okay.
But when people worry about like where do I start, it's like just start and draw the picture the way it kind of
Do it,
evolves
man.
in the problem.
Anthony, how is it going over there?
Good.
What number are you?
How are the contrast?
They're pretty okay.
Anthony, guess what song this is? Wait, I can't.
You suck.
I have no
Can
idea.
we? He's gonna get demonetized.
Is it blue for like the second one?
It doesn't matter. You could use whatever color combination you want.
Can I whistle a song on your sweatshirt and then I'll see if you're a true Ariana fan? Let me see. Let me see.
It's kind of like not to scale, but that's true.
That's okay. This could actually be good.
True. Can I see the other song?
Do you not know the entire?
Okay, sometimes I
You
forget.
don't know all the
I forget the
songs
song
compositions?
titles. I know the songs, but I didn't see the titles.
I think I might get comments
Fix
from
it.
people after they watch this video that's like,
Let the camera
your
record
sixth
them
period
and then
talks a
fix
lot,
it.
don't
I'm not a big
Get away
fan.
from me.
Safety.
is this where I should say, maybe this is why I do second period,
No, no,
because
no,
I don't
no.
have this background chatter going on that
We're
people
aiming
can
the camera
focus on
where
what's
Josh
happening.
draws. We're keeping the audience.
We're
entertained.
gripping the
Yeah,
audience.
we're literally, if we weren't here right now,
Okay.
they'd be clicking off. Yeah. They'd be like, God.
Well, I think I have problems even having people just click on. based on the views that I've
No,
seen.
I was watching the videos. They all have
Although
like
it will be
7
funny if all of a
views.
sudden I have a spike in views. People
They
are
only
like,
have
I just
7
gotta watch
views.
that 6th period. They're
No,
entertaining.
You better watch
you
it.
need to title it like 6th period not clickbait or something like that. Like
Oh.
no.
Yeah, you
have
write
to do
not
like
clickbait.
you have to do like
You get instant
a
views.
kid impales himself with marker. Not clickbait.
No.
And everyone will click on it, I swear. It'll have like
Boy breaks
a million
record.
views.
He didn't
We'll
really
like
break
make
the
money
record.
off of this, but not after I whistle. You'll get
He's
demonetized.
he's fast. He broke his fast.
Oh.
She won't get demonetized because no one can recognize your song.
Really good. If you can recognize it, maybe you're not a real fan. What about this one? This is a
I guess I
weird-
should connect them.
No, that's fine. We can live with this. Again, this is just to get the idea of how everything fits together.
Yeah.
Okay, so
Oh, wait, should
I think
have
everything looks like we got it put together correctly.
Maybe I should label them.
Okay, just label them with actually, you know what? I will do that
Okay.
because I'll get messy with this now.
I see.
Okay. Now the nice thing about this problem is that it goes back to our basic vector addition. We got 3 now instead of the 2, but the idea is we go through 3 segments and then we just want to know essentially what the resultant was from that. So we would label this one as our R, and let's start with this. If we were to say that this is A, how would we define it according to, or polar coordinates?
240 and 0.
It'd be 240 kilometers, and it would be 0 degrees because it points east. Let's say that we'd call this one B. What's our 350 kilometers, and then what would our angle be?
130.
130. Okay? Blue? Let's call this C. What would we have?
170
170
and 200.
and 200 degrees, because we'd have our angle for C comes all the way around here, and I'm going to extend this for, use blue there, so I'll do blue.
Confusing.
Our angle for the green one needs to be measured from there. Okay? So at this point, you just have to do a basic vector addition problem. Now, so I don't think I need to go any further than this in terms of setting it up. Now, number 5. Why would number 5 be a little bit different? If this was written like number 5, it would not be
5?
addressed, because I put number 5 up here as an extra, because there's I'll call it, I don't want to say that it's like super hard, but it has a twist to it. Because in problem 5, you will have an object that moves around and it ends up at another spot. But what it asks for is, what is the displacement that it has to go through to get back to its starting spot? So if that was the way this problem was worded, what's the only vector that would be different?
B to A, R.
It would be this one here, and what would be the only thing different about it?
The direction.
It would just point in the opposite direction. Now, if you can tell me, oh, well, to get Rx and Ry, I add all these things up, what would you then do to your Rx and Ry to get the vector that takes you back home? What would you do to those 2 components?
Change the sign.
You would just change the sign on them. Now, and then you would proceed with your Pythagorean step and your arctangent step. But by having them both be the opposite sign, and I'm only throwing this out, I'm not sure I'll accept this from people, because I'm giving this to you, you're not figuring it out.
Okay.
Because someone said, oh, couldn't you just make the magnitude negative? Not really, because the magnitude's always presented as a positive value. But what would end up happening if you just had a vector point in its opposite direction?
It would just be 180 degrees.
It would be rotated 180 degrees from that. So that's the part where I'm going to say at higher levels, people will give you credit for, oh yeah, you get how that works, and you just do it. Here, I want to see the nuts and bolts about why you end up doing that. And the nuts and bolts here are, instead of being the resultant, we need it to point in the opposite direction, and that means the Rx and the Ry, once you determine them, they point in the opposite direction, so you switch their signs. Yes?
I could think about it.
Oh.
Yes.
Do people in your other classes, like, they just go?
That's
Yeah.
what I've heard too.
That's what I've heard. And
Well-
they're like, we're honestly.
Can I just
Okay, we're done here now, right? So, you guys have time to work on this stuff.
Ow!